Dear students, this is our third module on the topic of data abstraction, and today we will discuss about very important data structure or data abstraction known as trees. So a tree is a collection whose entries have a hierarchical organization. So for example, we want to store the information of a company's hierarchy. So at the top level there is a president of a company, and then under that president there is a vice president of sale, vice president of finance, and vice president of services. And then vice president of services have regional service manager and regional service manager, different regional service managers, and vice president of sales have different regional sales managers. And such a organization, if we want to store, we can use the available data structure known as trees. And I again want to remind you again that whenever you want to store this tree, this will be stored actually in the same RAM which has addresses, and each address will store only one node. But all of the nodes will be connected using a data abstraction or data structure which we will implement as a tree. And here we have a constraint that no individual in the company reports to two different superiors. So this means that this regional manager will be reporting to only vice president of services. He or she is not reporting to both of them. So this means that the parent will not have two children. We should say that one children will not have two parents. So one parent might have two children. For example, this have these two children, but one children may not have or shall not have two parents. So here are different terminologies within the trees. One is called node. Each position in a tree is called a node. So all of the rectangular shapes in this picture are nodes. So one of the node is president, another is vice president of sale, vice president of finance, vice president of services, and so on. And what is the root node? The root node, the node at the top, base or root as in the below figure. So in fact, in trees, when we conceptualize, we say the node at the top is a root node. But actually, when we see in real life, the trees have their base in the ground. So we have reversed this picture, and we are seeing that this president is now coming over here, and all of its children are going upward. So actually in real life the tree is represented with this figure which is shown over here. So which has a base at the bottom. But to understand and to really conceptualize the things and to manipulate the data and to put more nodes and extract, delete, add nodes, we try to display the trees in this structure where the root node is at the top. So it was just to make you familiarize that why we say the root node is the top node. And then there are terminal nodes. The nodes at the other extreme are called terminal nodes, or sometimes called leaf nodes. So for example, in this tree, these are the leaf nodes which I have picked. Then there is another concept known as depth. Number of nodes in the longest path from the root to a leaf is called the depth. So for example, you can also say the number of layers available in the tree is the depth. So 1, 2, 3. Then children, immediate descendants are known as children. So for example, what are the children of president? There are 3 children of president: vice president of sale, vice president of finance, and vice president of services. Then parent, immediate ancestor is called the parent. So for example, regional service manager has a parent, vice president of sale. Then siblings, nodes with the same parent are called siblings. So these two are siblings because they share the same parent, and these three are siblings because they share the same parent, and all of these are also siblings because they share the same parent. And then there is another concept of binary tree, a tree in which each parent has no more than 2 children. So there is another concept known as subtree. So it is n is called a subtree if we select any node in a tree. We found that that node together with the nodes below it also have the structure of a tree. We call these smaller structure as subtree. So for example, we have made one big tree in this diagram, and we selected this node as a root node, and then we said that this one is a subtree having root node over here, and the branch, each subtree is called a branch from the parent node. So let's summarize today's module. We have learned today about very important data abstraction or data structure known as trees, and we have seen that why we need to conceptualize things like a tree and what kind of information we can store in the tree, and we have also learned basic terminologies within the trees.